Hello, this is Mr. Huber. In this lesson, we're going to learn about dividing polynomials, and we're going to use long division for our method in this video. We're going to see some other methods going forward here, long division. So I want to talk about long division in general. We want to write out long division just like we would if we were dividing two integers. Okay, so for instance, if we were going to divide 502 by 12, right, that would look like this, 12 into 502. And then we'd see, right, how many times does 12 go into 5? Well, it doesn't at all. So how many times does 12 go into 50? Right, so same here. And we want to include 0 as a coefficient for any missing term. Just like this is 502, we don't just leave out the 0 here. We're going to see what that looks like with polynomials, but keep in mind, zeros are important. We can't just ignore them or drop them out. We don't just make this 52. We have to have the 0 there, okay? And then we're going to start here. How many terms are in the divisor? This is the divisor, what we're dividing into the other number. Determines how many places to move over and start dividing. So just like here, there's 12, so I'm going to start over here above the 0. I'm going to go over 2 places. And we're going to see 12 goes into 52 4 times. 12 goes into 52 4 times. That'd be 12 times 4 is 48. So just like we're doing here, we're going to follow the same process. We divide polynomials. We're going to take the 4 and multiply by the 12. That's how we get the 48. And then what do we do with the 50 and the 48? We subtract them. Again, that's no different than we're going to see when it's polynomials. So we subtract, and we have 2, and we bring down the 2. We're going to see the same thing when we do polynomials. 12 goes into 22 one time. That's 12. We subtract, and we get 10. So our remainder is 10. So we'd write 10 over 12 as our remainder. So we have 41 and 10 twelfths. Okay? And again, same process here. Write out the division, okay? Include all zeros and missing terms, like we would have here. Find out how far to go over for your divisor into the dividend. Okay, we're going to divide. And this is where it becomes a little different. But the same process, whatever we put here, we multiply and then subtract, bring the next part down. And we'll see that with polynomials. Again, it'll look a little different, but we're going to keep that process going until we get down to where there's our remainder, which we can write as a fraction. All right? So let's see what this looks like for some polynomials now. So first we're going to write this out properly. So if we're going to write out the division here, we're going to have x squared plus x plus 3, and we're going to divide that into 2x to the 4th plus 3x to the 3rd plus 0x squared plus 2x minus 1. Okay. Very important here that we include the 0x squared. That's that missing term. There's no x squareds. We don't just ignore it. Just like in the other ones, 502, we had to have the 0 here. It's 0x squareds. We have to have the 0x squared here in our polynomial. So now we're going to take this and divide it in. We're going to go over 1, 2, 3 terms. 1, 2, 3 terms. So we're going to go 1, 2, 3 terms. We're going to start our division right above 0x squared. And the key here is to write above the x squared what we would multiply x squared by to get 2x to the 4th. We want to be able to subtract and have this term cancel out. So we want to have a 2x to the 4th here. So we need to write above here what will multiply x squared and give me 2x to the 4th. And that is going to be 2x squared. Okay? 2x squared times x squared is going to be 2x to the 4th. So we'll have 2x to the 4th. And then we're going to multiply the x times 2x squared. All right, so we're multiplying all of this by 2x squared. So 2x squared times x is going to be 2x to the 3rd. And then 2x squared times 3 is plus 6x squared. And now we're going to subtract, just like we did when we had integers there. We subtract them, even though they're polynomials now. This will cancel, right? And we're going to have 3 minus 2 is 1x to the 3rd. 0 minus 6 is minus 6x squared. And then we bring this part down, just like we did when they were integers, the 502 and the 12. Okay? And so now, above here, we're going to write what will multiply x squared and give me x to the 3rd. So what am I going to multiply to get x to the 3rd? I need to multiply x squared by x to get x to the 3rd. So I'm going to have up here a plus x. X times x squared is x to the 3rd. X times x is x squared. And x times 3 is 3x. So again, we took this x, and we multiplied it by all of this polynomial. We distribute it to the x squared times x and times 3. And now we're going to subtract. Okay, so now we subtract, and this should cancel. X to the third minus x to the third does in fact cancel out. Okay, then we're going to have negative 6 minus x squared. Negative 6 minus 1, right? There's a 1 here that's not written. So negative 6 minus 1 is negative 7x squared. 2 minus 3 is negative 1x. Okay, and then we're going to bring down the minus 1. And now, just like we did before, we need to put a number up here. So erase that line there. We're going to put a number right up here that's going to multiply by x squared and give me negative 7x squared. So what do I need to do? I need to have a minus 7 times x squared to get minus 7x squared. So let's do that. So I'm going to have minus 7. So it's negative 7x squared. Again, we're distributing it. Then times the x is negative 7x. And then times the 3 is minus 21. And now we're going to subtract these. Those cancel. Remember, we're subtracting. So we're subtracting a negative. So that's adding. Negative 1 minus negative 7 is negative 1 plus 7. So negative 1 plus 7 is 6x. And negative 1 plus 21 is plus 20. And so we're going to write that as our remainder. So it's plus 6x plus 20 over x squared plus x plus 3. Okay. But when you write your remainder, the remainder goes over what you were dividing by. Goes over what you were dividing by. That's the denominator in your remainder. Okay, so when we divide here, we're going to end up with 2x squared plus x minus 7 plus the remainder, 6x plus 20 over x squared plus x plus 3. Right, so that process, it takes a while. It's not easy. The more you do it, the more comfortable you're going to get, the easier it's going to go. Okay, the key is to find out where to start from. 3 terms here. We start over 3 terms. And then make sure whatever you write above the division multiplies this first term and will cancel with the first term here each step. Canceling out. All right? We're going to see a couple more examples here. Give you a chance to see some different things and practice on your own as well. Before we do a couple more examples, what's the only word in the English language, the only one, very odd, that ends in the letters MT? Very interesting. There's only one word where this happens, okay? You might find it in your sleep tonight. When you are dreaming, it is dreamt. All right, dreamt. The only word in the English language that ends with the letters MT. How about that? All right, now let's do another division here. Way more exciting than dreamt. Okay, so now we're going to have x plus 3, and we're going to divide this into x to the third plus 4x squared minus x minus 1. We didn't have to account. There's no missing terms, right? Third power, second power, first power, constant term, right? So there's no zeros, anything to add in there. And so now there's 2 terms here. We're going to start over 2 terms. We need to start up here, okay? If it's over the x squared, right, it's going to start with an x squared. And we need to see what we'd multiply by now to get this to be an x to the third. Well, x squared times x is x to the third, so we don't even need a coefficient in front of here. X squared times x is going to give me the x to the third. So I'm going to have x to the third, and then 3 times x squared, 3x squared. I'm going to subtract these. It cancels. 4 minus 3 is 1x squared. Bring down, right, the x. Then I'm going to find out above the x here, above the x, what do I need to write here? They will multiply x and give me x squared. Well, that's going to be an x. So I'll put up here x, and it's a positive x, because x times x gives me x squared. X times 3 is plus 3x. I'm going to subtract this whole thing. X squared minus x squared cancels. Negative x minus 3 is negative 4x. Bring down the minus 1. Okay. Now I want to put something above here that's going to multiply by x and give me negative 4x. So negative 4 times x will give me negative 4x. So I'm going to have minus 4. So when I multiply negative 4 times this, I'm going to get negative 4x and minus 12. So I have negative 4x and minus 12. When I subtract these, that cancels. Negative 1 minus negative 12. So negative 1 plus 12 is 11. So my remainder plus my remainder of 11 over x plus 3. And there's my answer. and I divide those two polynomials, that's my answer. X squared plus x minus 4 plus remainder 11 over x plus 3. All right. Let's see. One more here. All right, so we got one more example. When you are setting up the division here, x squared plus 0x plus 1. We have to account for that missing term. Don't forget that. Then we have 3x to the 4th minus 4x to the 3rd plus 12x squared plus 0x plus 5. So in both of these cases here, x squared plus 1, there's a 0x that I need to account for. Here, there's a 0x I need to account for. I can't just leave those missing. So now, I'm going to go through and I'm going to find there's 1, 2, 3, 1, 2, 3. So I'm going to start over the x squared. When I start over the x squared, that's going to be x squared. And I need a number there that's going to multiply x squared and give me 3x to the 4th. So I'm going to need a 3. Because now, 3x squared times x squared is going to be 3x to the 4th under here. So we're going to have 3x to the 4th. And now we have to make sure we multiply 3x squared times 0. So that's 0x to the 3rd. So plus 0x to the 3rd. And 3x squared times 1 is plus 3x squared. Now I can subtract these. That cancels. Negative 4 minus 0 is negative 4x to the 3rd. 12 minus 3 is 9, so plus 9x squared. Okay? And then I'm going to bring down this 0x. It's important to have that there. If I don't have the 0x's, it's going to throw off the answer. Okay? So now I need to multiply and get negative 4x to the 3rd. Right? I need to get the same term here, so I need something to multiply and give me negative 4x to the 3rd, so it's going to be negative 4x. So this will be a minus 4x. So when I multiply it by the x squared, I get negative 4x to the 3rd plus 0x squared, because I'm multiplying negative 4 times 0. And then negative 4 times 1 is negative 4x. And then I'm going to subtract these. Okay. And I'm going to end up with canceling that out. 9 minus 0 is 9x squared. 0 minus negative 4, so that's plus 4x. Okay. And then I'm going to bring down the 5. All right. And now I need to write up here what's going to multiply by x squared and give me 9x squared. So that's going to be a 9. So I would have plus 9 times x squared is 9x squared. 9 times 0 is 0x. And 9 times 1 is 9. And then I'm going to subtract. Let's cancel. 4 minus 0 is 4x. 5 minus 9 is negative 4. So I'll have my remainder plus 4x minus 4 over x squared plus 1. You can write the 0x in here as well. You don't have to. You can just take what's here. You don't have to worry about the missing terms when you write it in your remainder. But if you do, it wouldn't be wrong. So if you want to include the 0x over here, it'll still work. Okay? And so that's my answer. Okay? My answer here is 3x squared minus 4x plus 9 plus the remainder 4x minus 4 over x squared plus 1. So you see some examples there. It does take a while. You get used to the process. Take your time. Be detailed and organized in writing it out so that each step you can follow and, you know, get the right answer by finding what terms, right, you're going to put in your answer that will multiply and get the first to cancel out. And then the rest of it follows from there. Okay, so practice it out. There's a quiz you can take on Schoology, and we'll be able to get some more work on this polynomial long division.